Bismillahirrahmanirrahim. Let us look at another function. Okay, how to integrate inverse tangent, for example. Okay, so how to integrate inverse trigonometry. Let's look at either this type of the answer for that function is given in our formula list. Let's get the formula list. So this is the formula list given in our course. So integral of inverse, we do have the derivative of inverse trigonometry is given, but the integration of inverse trigonometry is not given. Okay, so let's learn how to integrate inverse trigonometry. So this is a simple notes given in our workbook, page 227. It says, okay, so integration involving inverse trigonometry. Okay, the same case refers when integrating inverse trigonometry function. The techniques of integrating by parts have to be used when integrating functions involving the inverse trigonometry. Okay, what is the formula? Do you remember what is the formula for integration by parts? So playing with integration by parts, we need to remember, okay, to change our equation or the inverse into this formula. Okay, uv minus integrate v du and the guideline. Okay, in order to choose our appropriate u. Right, so people, let's do this question together. I intend to do it together with you people. Okay, let's start with question number 1 first. Right, so we have an inverse trigo and dx. What is the appropriate u? So I that stands for the inverse trigo and dx is the algebra. So we start with the u being an inverse. Okay, inverse x, and then the dv should be the integral of, the v is the dx. We have to start with that first. Right, so this question then it will become the inverse tangent as we put the formula of integration by parts. Okay, let me put the formula again. Yeah, we change it as uv minus integrate v du. So hence we do need to find first what is our du dx. Okay, du. And to get the v, we need to integrate. So to differentiate, we need to look at the formula. What is the derivative of inverse tangent? Let's find it. So derivative of inverse tangent is given, which is inverse tangent u is 1 over 1 plus u square of du dx, meaning we need to differentiate further the u. Okay, 1 over 1 plus u square. So I put that and integrate this thing with v, we get the x. Let's plug in. Okay, the u inverse tangent x and the v, which is x. Let me put the x in front. Integrate v again the x and du is rearranging it. Du is 1 over 1 plus x squared dx. So then we are to know how to integrate this thing. Right, so let's use a simple u substitution that we learned earlier. Okay, so let's set, I'm not going to use u, let's say y. Okay, y being 1 plus x squared. We need to change everything in terms of y now for the simple u substitution. X dx. So x dx is dy on 2. So let's replace it here. Let me write back the question. So we have x dx being dy on 2. Let's put the 1 on 2 in front, dy. And this thing is 1 on y. So now the integral will become easy. Okay, so let's integrate the integral of 1 on y. 1 on y is what? There's a 3. 1 on 2, right? Integral of 1 on y is ln y. Okay, and plus c. Replace back your y in terms of dx. So that is our answer for question number 1. Alright? Okay, it's fun, right? Next, let's do number 2, 3, and 4 together. Okay, next let's do number 2 together. Okay, between algebra and inverse. Inverse I, algebra A. So the inverse comes first, meaning the appropriate U will be the inverse trigonometry. Okay, our variables is theta. So the dv is the remaining, which is theta d theta. Okay, so we start with that first. And then to replace into the u, v, okay, v du. So we need to differentiate this portion with respect to theta. We need to have a formula list. This is a formula list given to us in our Math 3 formula list. So let me put 1 plus, and our variable is theta. Alright. And then for this portion, we integrate both sides. So integrating theta with respect to d theta is formula theta is theta power 1. 1 plus 1 power 2 on 2. Don't put the c just yet, we put this c later on. Alright, so into the formula, check my work. U inverse tangent, variable theta. V, okay, let's put it in front. It's nicer. Minus integrate V. Here we have 1 on 2. I'm going to put the 1 on 2 outside. Okay, so we have this theta square. And du, as we rearranging it, du is d theta over 1 plus theta square. Okay, so we are left with this integral. Quite complicated. We need to solve this. Okay, so how do we integrate this part? Okay, theta square 1 d theta. Can we use a simple u substitution maybe? Okay, so here let's use a simple substitution. Let's see whether it works or not. Okay, so let's say this whole denominator being a y. Okay, so we need to be able to change everything in terms of a y, such that here we can see that the d theta that we need to replace, d theta is dy over 2 theta. Okay, so let's replace. Okay, d theta is dy over 2 theta. Well, but we still have this theta square. Okay, and you can see that we have 2 variables, meaning you cannot integrate straight away. Okay, so we should be able to change everything in terms of a y. Okay, so here we have 1 on 2, 1 on 2. Let me put it in front. This is 1 on 4. So here we have theta. Where to get the theta? So if you can see there, for this part, we are stuck. Okay, we cannot integrate. Because there are 2 variables involved. And in fact, if we are to replace the theta over here, such that the theta is y minus 1 square root. Okay, it will be complicated. So let's retry. Let's try it again. Okay, so let me erase this part. Okay, see how to integrate. So for this portion, we cannot use the u substitution that we tried just now. But yet we need to simplify this. Maybe we can try long division first. Okay, long division. See what happens. 1 plus theta square. Okay, let's divide this. So 1 of this thing, 1 plus theta square, and minus. Okay, this whole set. 0 minus 1, we get minus 1. Theta square minus theta square is 0. So we have a remainder there. So meaning what? Meaning this portion as we simplify it, it becomes 1 minus 1 over 1 plus theta square. This whole set is d theta. Right. So can we integrate? So here plus minus meaning you can integrate by separating. Let me separate this here, 1 to this portion. So here we can separate. So integrating this portion, we can solve it. It becomes theta. But half here, minus minus half, minus minus plus half. And here we are stuck. So this is an integral of the format of a square plus x squared. We have learned this before, right? Okay, let's look into our formula list for the solution of this type of the integral. So looking into our formula list, you can see the format out of the integral 1 over a square plus u square is this from this answer. Okay, it is given in our formula list. So our variable here is as theta, so the a here is 1. So we can quote that is the answer just now. So for this integral, we can actually get the answer where the a is 1 and inverse tangent, the u there is our theta, a is 1. So it becomes inverse tangent theta only. Okay, so let me write the answer back so that we can quote the answer. The u is theta, again the a is 1. Right, don't forget AC. So that is the answer for our question number 2. Alright. Okay, let's do more.